Okay, so negative 1750. What quadrant did we find? How did you know it's the first quadrant? You're correct. Use the word coterminal for me. Okay, let's go to principal angles. You're right, it is coterminal to negative 310, but let's keep it in 0 to 360. That's the simplest one for most people to think of. You're not wrong, I'm just saying that most people will want to work with 0 to 360. So it's coterminal to 50, yeah. So 50 degrees is a nice easy one to work with, which is quadrant number 1. Okay. How about 17 pi over 3? Anybody figure out which quadrant that's in? Quadrant 4? Yes, it's a quadrant 4 angle. So how did you figure that out?
It was a little less than 2 pi.
A little less than 2 pi. Can you tell me what it's coterminal with?
5 pi over 3.
Yeah, that's the one we're looking for. If you keep taking away 2 pi or taking away 6 over 3, you're going to end up at 5 pi over 3, which again is, if you think about where the grid is, this would be 3 pi over 2. This would be 2 pi. So it's going to end up somewhere in between those. A little more than 3/2, 1.5, and a little less than 2. Okay, so here's the most important idea. The first two things, coterminal and principal, those are a build-up to this. The reference angle is the most important thing that we need to talk about today. So the reference angle, this is the acute angle between the terminal arm and the x-axis. Now that sounds really complicated, but I'll show you a picture. It's actually pretty simple. Okay, so here's a picture of what it looks like. Sorry, acute angle between terminal arm and x-axis. Here's 4 angles. There's the angle between terminal and x-axis. Terminal, x-axis. Terminal, x-axis. These are the reference angles for those 4. Okay. So I'll put this in the calculator for you just to save some time as we are running short again. Okay. So it looks pretty obvious, but what would you say is, what do you notice about these 4 answers? 4 different angles. What's so similar about them? What do you think, Adriel? What's so similar about those answers? They're all 0.5, either plus or negative. So the only thing that changed was the positive or negative. The answer was the same. Well, if we were to take a look at those angles, this one here is 30 degrees. This one here is 150. This one here is the 210 degree. And this one here is the 330 degree. Okay. The reference angle of this one is 30 degrees. Okay. What's the reference angle going to be here? 30, right. The reference angle between here? Yeah, 30. To get from 180 degrees to 210 is 30 more. What about the last one? What's the reference angle? You probably don't even need to do the math on this, right? Yeah, 30. So there's an important connection that we're going to make. They all have the same reference angle, so the only thing that'll change in their answer is whether it's positive or negative. That's why a reference angle is so important. We can take all the possible angles and shrink them down to the range of 0 to 90 degrees. It just makes it smaller for when we're searching for our answers. Okay? So here's how you find the reference angles. In quadrant 1, the angle itself is the reference angle. It's already an acute angle. In quadrant 2, if I've got 180 degrees and take away the angle, it gives me the reference. So 180, take away the angle, or if I'm in radians, it would be pi, take away the angle. Okay. In quadrant 3, it's going to be the angle minus 180, or, of course, if we were in radians, it would be the angle minus pi. That's how I get this reference. And then finally, if I'm in quadrant 3, I'd be at 360 degrees, take away the angle, which of course is 2 pi, take away the angle. So if you need to calculate the reference angle, you need to find the principal angle and then make a picture like this in order to figure out what its reference angle was. Okay, so we'll try to find a couple together. So here's a couple in degrees. See if you can find their reference angles. Okay, so there's the first two reference angles. The first one is 40. The second one is 30. If we're working in radians, okay, that means the reference angle has to be between 0 and pi over 2, okay, in the first quadrant. So this one is actually too large. Okay? This is a quadrant 2 angle. It's just a little bit less than pi, which would be in quadrant 2. Okay? So this is a quadrant 2 angle, which means it's going to be pi minus 5 pi over 6, which means the reference for this would be pi over 6. And then finally in this last one here, negative 11 pi over 3. It's hard to work with pi in your calculator. You may want to just do it like this. Negative 11 over 3, and I'm going to add 2. So the next angle I get is negative 1.667. Add 2 again, and I get 0.333, or 1/3. So this is the angle I was looking for, pi over 3. So which quadrant is pi over 3 in? Is anybody brave enough or know their radians well enough yet? Can you think of where is that? Yeah, it's in quadrant 1. Okay, this is quadrant 1, so the answer is pi over 3. We've already got the reference angle. Now, how do you do radians? What if you're going, oh my god, Mr. Joyce, I don't see how to find the quadrant? Well, pi over 3 can convert into 60 degrees. If you're desperate, that's how you can find it. 5 pi over 6, 5 pi over 6, this could convert into, let's see here, 150 degrees if you were desperate. Okay? But again, you should do your best to work in radians when you can.